I, I, I hope that my speaking in English will not make the distance between you, because I imagine that not everybody is an economist from among you, and me, a person who is going to defend a little bit the environmental economics point of view on water resource management. So there's some misconception about economics, what is economics about, and what we do as economists. The first thing is we don't resolve the ethical questions. Economics is not a tool to find a solution to ethical, intractable problems. We only look for efficient, effective solution, how to reach the socially negotiated or socially accepted goals, an objective, environmental, economic, social, and so, but socially accepted. So that's the first. The second, we don't place the price because we like that. We instead of trying to find a common denominator of different things. We don't look at the total price, we look at marginal price. And this is very important. Marginal price is how much of a resource I would like to trade against something else, or how much money I would dedicate under certain circumstances to specific activity. In doing so, we are, because the financial resources are scarce, us is water, we are trying also to satisfy those needs which are most needed. So it's not, my preamble is simply to resolve a little bit the misconception and then explain a little bit more in detail what we do. I have prepared a presentation, basically an overview about what we have done in Fondazione Enrico Mattei, in my group dealing with natural hazard and water resource management, and in Euro-Mediterranean Center for Climate Change. So this is also a difference. I think that the topics we have addressed are touching upon the most important political questions in Italy, so I think I will entertain you to a certain extent. Right. I was asked to speak about integrated water resource management, and you all might know that the Water Framework Directive is the blueprint of IWRM in Europe. It's on European regulation, it's a framework regulation, it sets the common grounds for how we look at the resource and how we intend to manage that. It's meant to increase the protection of the resource, to achieve the chemical, physical, biological integrity of water bodies. It's also meant to increase the efficient use of resource and guarantee access and reduce the risk. So that's the stand of 2000, roughly when the directive was adopted. Now, since 2007, 2008, the number of objectives that we put on water and water resources have tremendously increased. Is the Strategy 2020, which looks for a set of answer to, looking for the growth potential wherever this can be found. And we can do there is a lot of things we can do in order to improve the efficiency, also financial or economic efficiency of resource use. We can reduce the damage to environment or to economy stemming from climate variability and extreme climate events. Again, in 2010, there was assumed started on fiscal harmonization of the policies across the EU member states. It's called European Semester. It doesn't have anything to do with the presidency of European Council. It's European Semester means consolidation on fiscal and monetary policies in Europe. And strangely enough, the European Semester found out that water is an interesting field also to help the countries dealing with financial crisis to find a way out. A typical example is Ireland. The Troika, composed by International Monetary Fund, World Bank, and European Commission, has imposed on Ireland that they have to sort of charge household for the water they use. Ireland is one of the last countries where the water service is not paid for by the households. And you might have seen the policy has been implemented since September. There was a huge social outcry, and there's a huge protest among the population who are not willing to do so. Why? I don't have a clear answer, probably because they were not used to pay for certain things, because they attach a certain fundamental values to water service. They hold a certain beliefs that water should be granted for free. What we speak about is not the water itself, but the service provided to the households. Right. Another initiative which is not really new, environmental tax reform, which was became one of the important European policy. It has been discussed since 1980s, 1990s, and the idea is very simple. Shift the tax burden from taxing the income to taxing environmental harmful activities or the land. This has been uptaken by certain member states, but not by all, and this is basically also found in fundaments in the European Treaty, where the polluter pays principle is one of the main fundamental principles of the European Union. Having said that, there was little achievement so far, and this is testified by 2012 Water Policy Review, but also by a number of other policy reviews at which we participated. We were fortunate enough to help to draft or collect the evidence leading to the blueprint for European, for safeguard of European waters, to the climate adaptation strategy, which was issued in 2013, and to a number of other policies. So we, from this perspective, I will not be able to show you all the research we have done, but I've made a selection of perhaps some most interesting for these occasions. I shifted from integrated water resource management to water security. This is not on purpose. It's not a new concept, it's basically the same with other words, but it stressed the security as opposed to threats, water-related threats and security. And it's a concept which embraces basically all kind of risk that relates to water, water pollution, water scarcity, floods, excuse me, and also losing the ecosystem services. What is interesting, again from economic point of view, Water Economic Forum, the annual report, which is called Global Risk Report, is based on a survey of perception of respondents from many countries around the world. And they are, every year they are asked to place, to rank the risk associated with certain threats. And you can see in recent years, water-related threats, that means water crisis, that means natural hazards, that means climate change, they are very highly ranked. And if you look here, you will find all of them in this part of the figure, which is illustrating the high impact and high probability of occurring. So this is just to demonstrate that there is an increased concern about water security, which englobulates all the concern we talk about so far today. OECD has a very interesting concept how to convey the water security or water-related risk. Basically, they frame the issue in 3 terms. Know your risk, target your risk, and manage your risk. So it's very appealing and simple structure, and I try to adapt my presentation to this structure. So I will speak briefly about our research on increasing the knowledge and advancing the science on understanding the risk, and then on managing risk, especially using the economic policy instruments. So there is a certain normative statement at the beginning, I would say, knowing better your risk or impacts of your risk is a principle of good governance, smart regulation, and better lawmaking. Behind every of these words is European policy or a range of European policies which advocate certain principles, how policy analysis should be conducted, or how the regulation, what kind of criteria a regulation, sound regulations should comply with. There is also a financial economic value of behind the concept of knowing better. If you know or have a good understanding of your risk, you might design more effective or more efficient risk reduction strategies. So you are saving money, you are not wasting money, you better target the money, public money, and use the resources which would otherwise have been spent for this purpose for other reasons. There is also financial value. You might sell the information on risk. Whenever you are buying a house property, you might be interested in knowing what kind of risk the property is exposed to, whether there is an insurance or any other financial risk transfer schemes or whatsoever. So for a small amount of money, you might capitalize on the knowledge which is already available, especially using the smartphones or digital technologies of today. So there is financial and economic value of knowing better. But knowing better is also connected to the purpose. It's purpose-driven. We are not collecting the information for itself. We are collecting the information for certain policies, advising the policies. And sort of the scope of the policy should be at the beginning of collecting the information or conducting the risk analysis. There are some basic principles. I think the impact assessment still suffers from little misconceptions, especially what is the direct, what is indirect loss, what is stock, or what is flow. I will speak about that by showing you practical examples. But basically, as economists, we are looking at the damage expressed at the efficient prices, not necessarily the market prices. We are looking at stock and flow might express exactly the same thing. They should not be mixed. So the stocks are basically a capital value of your future production or future flows. This is why for certain purposes you might be interested in looking at the stock damage, for example, caused by a flood. You might look at the cost of reconstruction of the houses or damage to the productive capital occurred. In other situation, you might be more interested in looking into how much production you have lost, for how long, especially for budgetary purpose, for fiscal policy of the country. You might want to know in advance how much less of tax revenue will collect at the end of the year. So there are different purposes, and you should choose the right assessment techniques for the given purpose. There was an interesting discussion in the scientific community about whether we can find a climate signal in the disaster losses, especially economic losses inflicted by disasters. And we have done a lot of research on that, but there is a good synthesis from the IPCC, both the SREX report and the fifth assessment report, which highlights it's not so much about the climate signal as much about the vulnerability increase. We sort of tend to place wealth in the harm's way. And that might have also historical grounds. There are interesting papers showing the same sort of bias towards increasing the vulnerability in the ancient civilization, which were established really in the most dangerous places. But this is basically behind what we can say so far with data or with statistical methods we can apply to those data about the changes, and I will talk about that a little bit later. There are a lot of limits or limitation behind that. We are working together with European Environmental Agency on a number of issues related to flood risk. We are trying to develop a European flood risk assessment module that would solve a number of issues, like whenever there is a disaster in Europe, having a unified flood model might produce a result that is comparable across the countries, that is reliable, that is sort of more accountable than collecting the data from different sources. That's one thing we are working on. We are working on a flood impact database. That means we are trying to collect the disaster records from different member states and try to harmonize them. But what we are recently working on is the normalization of the disaster losses. So the European Environmental Agency got the most comprehensive disaster loss data from Munich Re, Munich Reinsurance Company, which is a private company. The data is not publicly accessible, and this is why we were very happy to have that. And we looked into basically what's happening in that data. No, you cannot see that. So we have sort of accounted for wealth changes across the period 1980 and 2013, accounted for the changes in the currency values in Europe, collecting the information about 33 member countries of the European Environmental Agency. What you see is the distribution of losses over the years, and the categorization into hydrological disasters, climatological disasters, and weather-related disasters. What you cannot see, and I don't know why, it's any trend detection in this data is impossible, or at the first sight, impossible. It's simply because the bulk of the damage shown in the figure is caused by less than 1% of the events. So what we are looking at, it's something like 4,500 events, but only as many as 300 events caused more than 70% of the total damage over the whole period. So finding a trend in this data is really challenging. At the first sight, impossible. We are looking into regional disaggregation. We are trying to bring down those data to the regions and provinces in order to see perhaps some trends across the Europes. But this is the main obstacle in the first place. There is very small proportion of the losses of the events which cause huge proportion of the total damage. The second point is that we can collect the data about intensity of the events. We can collect data about the economic damage, but there is no way how to account for changing risk governance or changing the flood protection. So there's always a sort of residual uncertainty, which is the main reason why we cannot really find any climate signal in the disaster losses, together with the societal vulnerability trend I spoke about before. So this is one example. The other example is related to the European flood damage assessment model. We looked into different models developed by different member states of European Union or a European Environmental Agency. There is the most common model is what is called stage damage curves that links the land use with flood depth, flood velocity, and flood extent, and sometimes with some more characteristics. What we are adding to that in order to account for the variability of the valve in Italy and in Europe, we're looking at a set of economic and social indicators at regional level. That means NUTS 2 or NUTS 3, corresponding to the provinces or regions in Italy, which would capture the variability of the wealth distribution in the country. That's one way. The second way we are looking at is the spatial disaggregation of the GDP, which we can do a sort of translate the GDP, which is normally collected for the countries or for the regions, to translate that to a grid, which is 1 kilometer per 1 kilometer, or even less. In Italy, we have a good database for doing that. We are looking for corresponding data sets in other EU member states. But this is an interesting approach, which the value of which I will show in a second. We are trying to look into empirical evidence. Empirical evidence whenever the exact damage has been reported or collected. This is the case I think the reason why we cannot see this, it's PDF I have prepared also. Sorry for that. There is an animation behind. This is the reason why. Okay. So this is the Secchia levee breach that occurred in January last year in the Modena province. You might have heard about that. So this is the hydrological reconstruction of the flood, which was done by University of Parma. And working together with them, we try to approximate the economic damage, the structural, the stock damage. That means the damage to the productive capital and to the household, to the houses. There is also a collection of the losses going on, conducted by a civil protection agency in Emilia-Romagna. We are trying to get the empirical data by households, by every house, in order to corroborate the damage models we have developed or we have sort of translated from other countries. What is interesting is that in this case, the data which is available for exact damage models is there. There was a census and building, the population and building census conducted in 2011. So there is a lot of very detailed information available about every single house, which is also specially resolved. We have the maps of the buildings. We simply cannot convince ISTAT, the statistical bureau of Italy, to get access to this microdata, which is rich on information on the potential exposure, but which is connected with some privacy issue or confidentiality issue. So this is a sort of one thing we are doing a lot. On the one hand, we are developing the theoretical models explaining the damage. On the other hand, we are collecting the empirical evidence whenever this evidence has been produced by Italian authorities. The similar things, we are collecting case studies across Italy, including the Vicenza town and 2010 flood, where the damage are reported house by house, and we can use it for improving the assessment models. The other things we are doing is we are sort of combining, revisiting the past events that occurred in the past 50 or 20 to 50 years, and either keeping the events characteristic as they were. That means the precipitation intensity, the discharge, and whatsoever. But taking into account the increase of the vulnerability in the area. Or otherwise, we increase the intensity of the events in a way that it's consistent with the climate change projections, and to keep the vulnerability constant, just to have the comparison of what's going on in the territory in terms of flood damage. This is a case of where we took the 2000 flood in Piedmont and the discharge of Po River, and we simulated the same levee break that occurred in 1951. And we developed different scenarios that slightly increased the intensity of the events, again in line with the projections of the regional climate model of Euro-Mediterranean Center of Climate Change. We are doing also, we have conducted similar studies not only in Italy or in Europe, but also elsewhere. I led the climate risk assessment of the Republic of Mauritius in 2012. In that case, we ran the regional climate simulation models. The hydrological models, we identify the area exposed at risk and quantify the damage. In this case, we got we handed over the report in December 2012. And in March 2013, there was a huge flood affecting the capital of Mauritius, and the flood occurred exactly in the areas which we identified as being at high risk, which is a sort of confirmation which doesn't really make you happy about, but it at least helped to substantiate and show the relevance of the investment we have suggested to the government of Mauritius. on the opposite way, we are looking also in the production losses in terms of flow. So far I spoke about the damage that would occur to the physical stock, houses and machinery and manufacturing. It's interesting to look also into how much production losses you will have under different hazard scenarios. And again, the whole chain of the modeling, it starts with the GRC, the ensemble of climate projections, the GRC hydrological model list plot, and we conducted the analysis using a computational general equilibrium model in order to quantify the production losses across the regions. Macroeconomic model is regionally based. That means it shows also the losses region by region. What you can see and notice immediately on the result that there is a huge distributional effect associated with any economic losses of this magnitude. So why you can see the northern regions, Piedmont, but especially Valle d'Aosta, Lombardy, are likely to suffer higher increases of the annual expected damage due to the climate change. There are some regions that are scheduled to gain a little bit exactly because of the damage. This has to do with the substitutions. Whenever there is an enterprise or a company not able to deliver a service in the northern Italy, somebody else delivers the service, perhaps a different price, but it fills the gap. This is the power of the market, where any producer or almost any product can be substituted by somebody else. Because of this flexibility of substitution, there are some regions that will likely gain a little bit from the climate change, for the climate change-induced increase of the flood damage and risk. We looked also into drought. Again, you can see the same distributional effect. We looked especially in the Po River Basin, what was the economic impact of the 2003-2007 drought, or, well, heavy drought in the recent memory. But not only in the yield losses, we looked also into the labor, productivity losses, and employment losses. So we combined, again, the regional data set from ISTAT, from Statistical Bureau, with the farm level data that's FADEN. It's a network of European farms for which the detailed farm level information is collected in order to inform the European policy. So combining the two effects, we have been able to identify the specific and differentiated effect. But what you can see on the map is that even in the situation of 2003 and 2007 drought, some provinces or agriculture regions have gained. They have experienced a higher yield in that year compared to the average of 10 years average or 5 years average, while other provinces or agriculture regions lost a lot of value. So this is a typical sort of effect in economic terms. The disaster impacts are producing distributional effects. Somebody might gain, somebody loses. It doesn't say that the sum is zero. The losses might outweigh the gains, but still there might be some small gains by somebody. The same, we were talking about the energy and the climate variability impact on energy. We looked into, especially because of the energy crisis, which was declared in 2003 because of the low river flow of the Po River. So we looked into the large hydropower plants and thermoelectrical plants in the Po River Basin, identified the largest ones, and looked into how the future river discharge might reduce the energy production of those plants. We found out that for the 10 largest plants, which at that time accounted for 50% of the production, average production of the 4 regions, the loss might be quite consistent. It was between 6 and 21%, which was high in my opinion, but it was 2 to 7% production losses at the Italian level. In the meantime, the situation has changed. We looked at the vulnerability of thermoelectrical power plants. You might have had in 2013 the renewable sources of energy for the first time in May 2013 and 14 again superseded the thermoelectrical energy production. So basically, what is the outcome? We have the thermoelectrical power plant working at the capacity of 40 or 50% of the capacity because they are too expensive, while the most energy, especially in the summer or late spring, is produced by renewables. So that just add to the context. Perhaps the thermoelectrical power plant is still vulnerable to low river flow, but the general importance of thermoelectrical energy generation is reducing. Now a little bit about the kind of policy instruments or intervention we are looking at, both for European institution or for European projects. We are looking at water pricing, water tariffs, taxes, land taxes, pollution taxes. We're looking into risk transfer schemes, insurance, multi-stakeholders partnership, and I have picked up a few examples for you. The first is interesting because it connects the land and water. It's the Veneto regions after the 2010 flood introduced a flood servitude. You might have heard about it. It's simply, instead of a landowner being expropriated of the land because the land is designated for public uses like construction of dried polder or reservoir, flood reservoirs. This piece of law enables the regional administration to impose a burden on those landholders, saying you have to, you continue to be the holder of the land, but whenever I need your land, I will store flood water on your land. So in a specific case of dry polder close to Vicenza town, it works like it's a reservoir. It's cassa di laminazione, basically, which is flooded only occasionally. That means the farmer can cultivate the land and it's compensated upfront at the beginning for the losses, but the compensation accounts only for 2/3 of the value of the property if it was expropriated. So we looked into that, whether this is fair, economically fair, or whether there is the way how the losses are compensated, whether there is something wrong with that. But we also looked into the value of the dry polder for reducing the damage. And the two maps shows basically the difference between the flood extent with and without the polder in the municipality of Vicenza. There is a small economic benefit, let's say, from the scheme. What is the burden? On the burden side is a proper management of the dry polder requires a precise flood forecasting. Because if you open the gate of the polder too early, you simply fill it out with water, and it doesn't have any impact on the peak of the river flood. So I guess what might be the side effect of this is, again, it will fuel the discussion about whether the hydrologists are able, or the civil protection is able to foresee the disastrous event and the peak discharge, and it might again fuel the discussion about the legal responsibility of not providing the service in time. In Emilia-Romagna, we are looking in a different situation. It's not an area that is equipped for keeping flood water, but it's simply an unequipped area, any agriculture area, because the damage on the agriculture area is order of magnitude lower than in the towns. The sort of economic principle is to shift the flood water from high value land uses to low value land uses. And in this case, there was a drainage system damaged after the 2012 earthquake, and the interregional civil protection mechanism was mobilized, and they identified the options of controlled floods as a way of solving the situation. It looks like this way. There's an area designated as potentially area that could be flooded in the case this is necessary. But there is no physical structure that holds the flood water. It's basically controlled flood that I designate this area simply for the damage in order to avoid damage somewhere else. The key principle here is to find an equitable compensation system and cost recovery. So we are looking into different economic instruments like land taxes or the service fee or the tradable property rights that could guarantee the cost recovery in this situation while helping to reduce the flood damage. So what you see on the maps, those are different scenarios of precipitation intensity combined with infrastructure failure, because the earthquake has damaged basically the water pumps, pumping the water from the drainage networks into the Secchia River. You might have a combination of different hazard exposure. So this is what we did, and we calculated the damage, and we are working on a fair, equitable distribution of those losses and cost recovery, which is, let's say, acceptable by the property owners in the area. There is a lot of talks about state compensation, which is a sort of outgoing model. In Italy, it's probably in the very last phase. There was already in 2010 a proposal for introducing voluntary or mandatory disaster insurance, because the state budget during the financial economic crisis was not able to guarantee the same compensation as in the past. European Commission has looked into that as a potential source of European policy in 2013. They published a green paper asking, is it a viable option or shall we go that way? And so far there is no unique answer to this question, but we are translating our damage assessment in the areas where we worked into let's say, fair insurance contracts or insurance scheme. It would mean we would not go for an actuarial pricing model. That means you are responsible for all your risky choices. So you bear the whole financial burden of your property's hazard exposure. But to something which is more a sort of choice-sensitive fairness, where we would simply have a sort of cross-subsidies for the hazard exposure which is not your fault or not the fault of the property owners, because of the historical reason, because of the way how the water was managed before, because of the development rights and property issued in the past. So sort of disentangle what you can do on your private, on your own way in order to reduce your damage, and factor this into the insurance scheme. We looked also into how the 2014 reform of European Solidarity Fund has influenced the way of governments perhaps getting less interested in the solidarity payments. European Solidarity Fund, you might remember, was established in 2002. It was during the Romano Prodi Commission. It was Prodi who sort of pushed it forward back in August 2002. And it's a sort of helping the most disaster-stricken countries with the financial burden in the case of really heavy disaster. In 2013, the criteria for accessing the Solidarity Fund were changed, and there are a number of issues which we highlighted to the Commission, that it's less solidarity-based as it used to be. You might also know that Italy is the major net receiver from the Solidarity Fund. For the 2012 earthquake in Emilia-Romagna, Italy got 660 million euros. It's something like almost 70% of the annual endowment of the fund. And over the period 2002 and 2013, Italy is the largest beneficiary of the Solidarity Fund. Why the reform would simply make the past disaster not eligible. So if the same type of disaster occurred in the future, several of the events for which Italy got the aid from the fund would not be eligible anymore. Other type of research we are looking at, it's the demand of willingness to pay of the farmers. This is again for the Emilia-Romagna region, and based on extensive data of the farms. So what is the willingness of the farmers to pay for insurance contracts? So how much of their profit they would like to sacrifice in order to have income stabilization insurance? And it's, there's interesting theoretical model behind. I don't want to bother you with that. But what I wanted to show is, again, the differentiation across the region, which roughly reproduces the same exposure or the gains or losses from the drought. This type of analysis might also be used for introducing a scarcity pricing for the agriculture purposes. Might be introducing to, might be used for substantiating a water reform, water concession reform. So that this provides an interesting insight for the different farmers, what they can do with the entitlements to withdraw and use water. So to wrap up a little bit, I know that I rush you through a number of applications, but basically what we are looking at, or what I showed in my talk, is first we need to better understand the impacts of climate variability and extreme events. And it's very important for both disaster risk reduction and climate adaptation. It's always like, and this is, somebody said that economists are closer to the policymakers. It's simply because those with numbers are usually better off than those without. That holds true. What we need to ensure that the numbers are reliable and they are reflecting perhaps the variety of the values. What is very important is distributional effects of disasters, or water inefficiencies, or the cost caused by inefficient water use. Financial viability of service provision is very important. Equitable cost recovery, trying to find the right economic incentives to change the behavior. It's very important. And at the same side, the legislative and regulatory environment, that it's nurturing, that it's enabling perhaps this soft pushing, or the set of incentive for everybody to reduce or make better use of the resource, that's absolutely vital for designing efficient and effective policies. There is a number of other research we are looking into. It's basically capitalizing on the research we conducted over the past, and that fed into the National Climate Adaptation Strategy, which CMCC coordinated, and we did some recommendation for the Po River Basin. And in the next step, this research will inform the action plan and the specific measures to be taken in the local regional scale. Thank you very much for your attention.